Hello and welcome back to Matt's Automotive channel. In this video we're going to be installing a set of 410 gears into my wife's GT500. My approach on this video is going to be a little different than in previous videos. I'm going to do a very detailed step-by-step A through Z process and hopefully leaving you with no unanswered questions by the end of the video. I have found that most install videos tend to fall into one of two categories. Category one is where they kind of glaze over the process and just kind of highlighting the main parts, but kind of leaves you with a lot of unanswered questions. And usually these videos are generated by vendors trying to sell you the gears, so you'll buy them and not get discouraged. And then the other type of video tends to be more detailed, but usually just focuses on one aspect. Like somebody started one of these gear set installations and then found some problems, and then they'll make a video with the specific problems that they found. So my goal with this video is to pretty much cover absolutely every aspect of the gear change. Well, with a video that's very detailed, it's going to probably tend to move a little slow, and for anyone who has any experience at all doing this sort of work may find it kind of boring. However, if somebody's really experienced, they're probably not watching this video to begin with. So anyway, this video is going to be geared for the person that's doing this job for the very first time, and so I'm just going to throw everything out there, tell you what everything is for, all the steps, all the processes, all the issues that you could potentially run into when doing one of these gear swaps. Now, it's important to note with this particular job, I'm going to change out a gear set that is perfectly fine. There's absolutely no issues with it. We just want to go to a more aggressive gear, so it's just a funner car to drive. With that being said, that's going to change my approach and the way that I do things. It's going to be a little different than if you were replacing a gear set that was in bad shape for some reason. So anyway, with that said, let's go ahead and get started. All right, so let's get real basic here to begin with. Exactly what is a 410 gear, and why is it an advantage over a 355 gear? What do those numbers even mean? Well, what it means, it's a ratio basically between the number of turns of a pinion gear versus the ring gear. So with any gear set, you can determine what the gear ratio is if you count the number of teeth on the ring gear, and in this case it's 41, and then count the number of teeth on the pinion gear, which happens to be 10, and then you take 41 and divide it by 10, you're going to get 4.1. So this is a 4.1 gear set. So basically the engine's going to have to spin a little faster to get an equivalent number of turns of the wheel. Why is this an advantage? This is going to actually provide more torque to the rear wheels. Not more horsepower, more torque. All right, so how much more torque? Well, our stock gears are 355, and the new gears that we just bought are 410. So if you take 410 and divide it by 355, you get 1.15. So basically, it's going to put 15% more torque to those rear wheels. But in order to do that, the engine is going to have to spin a little faster. And because we're changing this ratio here, it's going to throw off our speedometer. And in this particular case, it's going to throw it off by 15%. So in other words, now if we're traveling at 60 miles per hour, we have to multiply that by 1.15, which is equal to 69. So our speedometer is going to now read 69 miles per hour at 60. So anyway, this is no good. So what you have to do is correct the speedometer. And depending on the year Mustang you have, there are different ways to do it. Some of them, the earlier ones, they'll have a little gear, worm gear, in the transmission that you have to swap out. With the newer Mustangs, it can be done with a handheld tuner. All right, the gear set that I picked up was a Ford Performance. And if you have a Ford, I highly recommend that you stay with Ford gears. You will more likely have less problems swapping these out and not have to deal with pinion depth and that sort of thing. So these should fit, hopefully, without having to change the pinion depth, which can be quite involved. This particular kit also came with 2 quarts of Royal Purple gear oil, 75W140, and then a 4-ounce bottle of friction modifier, which is needed with any traction lock differential. It also came with all the bearings, so we're going to go ahead and replace them all. You get two carrier bearings, an inner pinion bearing, outer pinion bearing, of course some new bolts and some gear marking compound and some thread locker. The gear set also comes with a new pinion nut and then also a new crush ring. The only problem with this kit is they give you 2 quarts, when in actuality you're going to need more like 2 1/4 to 2 1/2 quarts. So before you even start the process, go ahead and purchase yourself another bottle of this. You're going to need it. All right, so the advantage of going to a higher gear ratio is more torque. You're going to get off the line quicker. The engine's going to get up into its power band quicker. Sounds all great. So what's the downside to it? Well, there's a few downsides to it. Number one, you're going to suffer a little bit in the mileage category. And also, you're going to lose a little bit at the top end by about 15%. However, that's not a huge disadvantage since most of us don't max out our cars usually. We're more interested in just accelerating quickly, and we rarely ever hit the top speed of what a car is capable of. So this is going to be pretty beneficial. Okay, the other problem with going to this is the more torque. You think, okay, great, I'm going to get off the line quicker, I'm going to get a lower quarter-mile time, and that's true, providing you can put all that power to the ground. It may be that you're going to need to get some better tires now as well in order to take full advantage of this additional torque. One other consideration, if you're changing gears to get a better quarter-mile time, do your research and find out what gear set's going to work best for you. In other words, you don't want to put a gear set in the car that's going to make it so you have to shift, that last 100 feet of the drag race, because you're going to lose, a tenth or two in terms of just having to shift. So in that case, you might want to go to something that might be slightly less aggressive, but nonetheless, you're going to be shifting more frequently with a gear set that has a higher numeric ratio. All right, before we go any further here, you can see that there's a couple things that are going to be in the way. So we're going to have to pull this panhard bar and also swing the sway bar length down and out of the way. So that'll give us good access to the rear differential here. So I'm going to go ahead and pull that now. We'll also need to get the wheels off as well. I pulled the bolt off on the driver's side of the panhard bar. On this side, even though you take the bolt out here, it can still be wedged in there pretty good. And in order to drop this down, you may need to loosen this upper bolt here, and that'll allow this metal to separate and the bar to drop down. So I'll give that a shot here. There we go, coming down. So I'll make it a little easier. And yeah, that part's out. And let's take out this other bolt, and now it's free. Now for the sway bar, I'm not going to remove the whole thing. I'm just going to take out the bolts for these upper end links on both sides, and then just swing the whole bar down. All right, now we can go ahead and pull the diff cover. From the factory, these diff covers come with RTV. I had to change the oil in this when I got it, and so I ended up using a gasket. So it'll be much easier to get off just with the gasket. Okay, I'm just leaving the top bolt in here so it doesn't fall off, and it's already coming out. With the RTV, you're gonna have to pry this off a little bit. But the gaskets makes it very easy. Very thick oil, and it doesn't drain very quickly into the pan here, so be careful of that. If you don't have a pan that has a really good drain in it, it could overfill easily. Okay, now we can take the last bolt off here and remove the plate completely. And there we go. right, I will warn you, this is probably one of the worst parts of the job. Not because it's difficult, but because it stinks incredibly bad. The 4 ounces of friction modifier that goes into these rear ends is very, very stinky, odoriferous fluid. And so definitely wear gloves when you get this, when you try to scoop all this stuff out. If you get it on your skin, your hand's gonna stink for a couple days. All right, next part of the process, we'll go ahead and pull the drive shaft off the pinion flange here. But before we do that, we want to mark both the pinion flange and the drive shaft so we know how it came off and we can put it back on. I like to put not just one, but 2 different markings on it, just in case one of them wears off in the process. I'll put 2 marks here and 2 here. Okay, then we can go ahead and pull the bolts off. All right, if you have an impact gun, you can just go ahead and zip these off. Otherwise, you're probably gonna have to go up and pull the handbrake up and then lock this to prevent the drive shaft from spinning, and maybe even put it in gear. But we got an impact, so we'll go ahead and use that. All right, and then once you have the drive shaft off, instead of removing the whole drive shaft, I find it easier just to tie it up. I have one of these little twisty ties and just kind of tie it off up there to the upper control arm, and then it's out of the way. Just so as long as this pinion flange can spin freely, you should be good to go. All right, you remember when I said that there's absolutely nothing wrong with this gear set, and that's going to make a little difference in our protocol here. This is one of these differences. I'm not going to just go ahead and pull this thing out right now. What I want to do is hit this with a little bit of brake clean, and then get all the oil off of these gears. Because what I'm going to do is put some gear marking compound onto them, and then we'll look at the pattern. When you do this job a lot, you'll get used to it and know what the pattern should look like. But if you're a first timer, you may not. And it seems like all the diagrams that are available on the internet are always a little different. So anyway, since we know that this is a good setup here, this will kind of benchmark what the gear pattern should look like once we put the new gears in. So this is step 1. And then the other thing that's going to be a little different is once we do pull the carrier out, we're going to measure the pinion depth. And whatever method we use to do it, as long as we're consistent when we put the new one in, we'll be able to check it. That way you won't need a whole bunch of fancy, expensive equipment to do pinion depth. Now, if we had damaged bearings and whatnot, obviously we wouldn't be doing this. But since it's a good setup, let's just see what it looks like with a good setup, and then we'll know how our final installation should look. Okay, so now I'm putting a little bit of this gear marking compound on here. I'm gonna put it on several teeth. And you also want to make sure to get it on both sides. On the convex side, the curve outward, that's the drive side of the ring gear, and the convex side is the coast side. And we're gonna check the pattern on both sides. So now that I got the gear marking compound on there, let's go ahead and spin it a little bit and see how these things line up. So I'll create a little bit of drag here with my hand. And then we'll go back the other direction so we get both sides of the gear. And we'll take a look. Okay, we can kind of see now how this is matching up. There's still a little bit of oil on there, which makes it a little more difficult to see. But you can see it's a fairly long path there. But it kind of disconnects near the end, which is over here on the outside, that's the heel, and the inside here is the toe. And it kind of disconnects there too. And okay, that's the drive side. So now if we spin this and look at the coast side, we can see a very similar pattern there. So when we set up our new gears, we want it to look pretty much like that. Okay, the next thing we want to check is the backlash. It is supposed to be 10 thousandths plus or minus 2 thousandths. So between 8 and 12 thousandths is what we should find. Okay, let's see, I'll get it set here on 0. Okay. Yeah, it looks like it's right there at 10 thousandths, between there and there. So that's pretty much spot on. And when we set up the new one, it needs to be the same. There are a few specialty items that you're going to need when setting up a rear end. One of them is a dial indicator. This one's being held on with a magnetic base, real convenient for setting these things up. All right, we're going to have to pull the axles. So the next thing we want to do is get these brakes off. I've already taken the bolts off the back side of the caliper here. And make sure the brakes off in the car as well. Problem with these is they've been worn so much, there's a huge ridge here on the outer side, so it's a little difficult to pull those off. I'm probably gonna have to pry it. Okay, I'll just use a crowbar here to pry it off. Yeah, if your brakes aren't real worn, this won't be much of an issue. They should come off pretty easy. All right, now I've got it mostly off with the crowbar, so I'll just tap it the rest of the way off. There we go. And then we don't want to let this brake hang from the cable, so it'll stress them. So I'll get something to tie it up here with. All right, for the time being, I'll just use one of these little mini bungee cords here and just wrap it around the spring. And there, that should hold it for now. All right, now we'll need to take the disc off, and then also the wheel speed sensor, which is on the back side here, because we don't want to damage that when we pull the axle. This is an indication here that these have never been replaced. These little keepers here are put on during assembly. They don't need to go back on once you have them off, so just cut them off and just discard them. Okay, and then once that's off, the disc should pull right off. Unless it's rusted, in which you would have to hammer it off. All right, now we can go ahead and pull the wheel speed sensor. This is a 10 mm here. I'll go ahead and take this bolt out. And then once that's out, we should be able to just pry this out just a little bit. Do it very carefully though. This is plastic and could easily damage it. There we go. Oops. There we go. All right then, now we'll just repeat the process on the other side. All right, next we can go ahead and remove the locking pin bolt here. And then once that's out, we can go ahead and rotate this down, push on the other side, and then the pin just comes out. All right, the purpose of this shaft here, it serves actually two purposes. One is it's the shaft that these spider gears spin about, and then also it is what holds the axles out. I'll push in on the axle here from the outside, and you'll see it move in. And when you push it in, that's going to give us access to the C-clip that we'll just pull out with a magnet. And so once we pull the C-clip out, we should be able to remove the whole axle. All right, so let's go ahead and push the axle in. That will expose the C-clip here. And then you should just be able to go in here and pull the C-clip out. We'll try a magnet here. Okay, there we go. like so. All right, now that the C-clip's out, this axle should be free to just pull straight out. When you pull it out, kind of hold it up from the bottom here so you don't drag it along the seal, so we don't damage the seal. And there we go. All right, one thing to note here, these C-clips are not the same on both sides. One side has kind of a flat side. You can tell it's a 90 degree here along the edge. And the other side here is smooth. And it's the sharp side, the 90 degree side, that'll go towards the inside of the axle. So when you put it back, make sure it goes back in that fashion. And it's pretty obvious too, you can see the wear marks there, and that coincides perfectly with this axle, whereas if you did it the other way, you can see it does not. Now, if your car has over 100,000 miles, this would be a great opportunity to pull the axle seal and the axle bearing and replace it. This car only has about 56,000 on it, so I'm not going to bother. Now we just need to repeat the same process and pull the axle out on the driver's side. All right, another thing to note here is you may be asking yourself, are these axles interchangeable? No, they're not. They're two different lengths. You can see the one on the driver's side is a little bit shorter than the one on the passenger side. I don't think you can really screw up if you did try to put them back incorrectly. It would be pretty obvious. You wouldn't be able to get the C-clip on the shorter one. Also, while these are out, it's a good opportunity to clean up those tone rings there. Those are the rings that the wheel speed sensor uses to measure speed. So just make sure that those are free and clear of any debris and dirt. All right, next order of business is to pull the carrier out, but in order to do that, we need to pull these bearing caps off. Now, the thing with these bearing caps is they look pretty much identical. They have the same numbers, the same markings, and these caps need to go back in the same position, same side, same orientation. So what I like to do is mark them, and so I like to put marks at the top here so I know that when I put them back in, that this goes to the top and they're not reversed. And I like to put 2 marks on this side, 1 mark on this side, so I know which one's left and then which one's right. So just take a hammer and chisel and just go right here on this side here. Put 1 mark there, another mark there, and then just 1 over here. There, that way I won't have any confusion when putting it back. Let's take a little closer look. You can see I got 2 marks there on the right side and at the top, and then just 1 mark over there for the left. All right, now let's try to pull these off. I'm going to loosen them first with the breaker bar here. This is a 19 mm. I think these things get torqued down to around 100 pound-feet, so they're on there pretty good. Okay, there we go. Okay. Okay, now we're ready to pull the carrier out. When you do this, be sure to wear some fairly thick, heavy gloves because these teeth here can be kind of sharp and you definitely don't want to get cut on it or pinch your finger or anything. So wear some thick gloves. Also, on each side of the carrier here, there are shims. When you pull it out, don't get them mixed up. We're going to measure them, and these shims need to go back into the same place. That's if we don't have to mess around with pinion depth and reshimming things, but good idea just to keep them where they are. And then also measure both of them to see the total thickness, because if we end up putting different shims in, that overall thickness will need to be the same. So the best way I found to pull this out is just to get a crowbar, put it under the slip here, and then just kind of tap it. There we are. And then lift her out. Hopefully those shims stay in place. Bearings are not. Put your hand on the side there, hold those bearings in. Okay. We can set that down. And then right here is going to be the shims. Here's the right one. Put that over on the right side. And here's the left one. Put that over there. And then we'll measure them. All right, so before we get these left and right ones confused, let's go ahead and measure them. I have a little micrometer here. And it looks like the left one is 0.275. So we'll go 0.275. And let's see what the right one here is. And wow, pretty darn close. Looks like 0.273. So if we end up having to add shims, delete shims to get the proper backlash, the sum of these two numbers is what we want to have total, because that's what's going to determine what the carrier preload is. All right, it's time to do another one of those procedures that we wouldn't do if we had a damaged gear set. But since we know this is good, we're going to measure the pinion depth now. And I'm going to need two things to do that. I have this Radtech pinion gauge tool. I'll give you the model number to it in the descriptions. And then also a caliper with a plunger on it so we can measure depth. So the way that this works is backside of this pinion depth gauge has a little nylon piece. That goes into the center of the pinion here, is that little hole. Make sure that it's free of any debris. Also, same thing on the pinion gauge. And then this little portion here fits right into where the bearing race would go. Make sure that it's not caught on this lip. Make sure it goes onto the inner portion there. And then we can take our plunger depth gauge here and then measure this. So push that in. Okay. And then we'll go ahead and lock this and then take it over to the workbench and read it. And the nice thing about this is when you use this, just this gauge alone, you need to do a little bit of math. You got to measure the thickness of the pinion head here, and I think you subtract it from 0.442 or something like that. I'll explain this later when we go over to the workbench. But anyway, the thing is, everything has to be measured very accurately. You know, the caliper has to be calibrated. And anyway, it just introduces the possibility for more error, whereas we're just taking a particular reading here. I mean, this doesn't even need to be calibrated, really. It just needs to be consistent. So when we put the new gear set in, we want to achieve the same number. So let's go over to the workbench now. One other thing, when you do take this measurement, do it multiple times and make sure that you can get a consistent number each time. And then also, when you have the gauge in here, kind of rock it back and forth and put pressure on this, and then just observe the gauge. And when you get to the shortest distance, that's the number you want to use. Obviously, if you go off to the side here like that, it's going to make that distance appear longer. So really, the shortest distance here that you can measure while rocking it back and forth, that's going to be your depth. Okay, so over here, it looks like we measured a distance or a depth of 0.536. So that's what I'm going to put for my distance here for pinion depth, 0.536. And then we'll go ahead and go back over to the car and pull the pinion, and then we'll go through the procedure that they want you to use with this. And we'll see how close that is, just for curiosity. All right, let's go ahead and remove the pinion nut. If you have an impact, you can just go ahead and take it right off. If not, you're going to need a pinion flange holding tool, and we will use that tool when we put the nut back on, but I have an impact, and so just to get it off, I'm just going to go ahead and use this right now. Okay, then we'll need to get a puller through. Usually you have to get a jaw puller, but this seems to be on here fairly loose. So I'm just tapping it off with a rubber mallet here. That's the easiest pinion flange I've ever removed. Okay, and then we'll have to pound this in. So what I'll do is I'll get the pinion nut so we don't damage any threads here, screw it on a little bit, and then we'll just pound it and then pull the pinion out from the other side. All right, again, when doing this, anytime you're handling these gears, put some gloves on. Okay, so I'll go ahead and try to hammer this out from the other side now. There we go. All right, so in order to measure the depth of this pinion head, we're gonna have to pull this bearing off. And let's see, here's the crush ring. Just for comparison, here's the old one, and here's the new one. And you can see how much it gets crushed down in the process. You can also replace these crush sleeves with a solid metal sleeve. Well, I'll go into that a little bit later as to the advantages of each, but this is not your only alternative. So anyway, let's go ahead and get this, this bearing off. And we're gonna use this clamshell bearing puller. This thing is absolutely amazing. I tell you, if you're doing more than one or two of these gear swaps, it's worth investing in these. The alternative is not so great. Oftentimes with a regular type bearing splitter, you're going to damage the pinion bearing. So anyway, let's go ahead and pull that off. All right, if you're not using this, then odds are you're going to use a bearing splitter that looks like this. And it will get the job done, but odds are you're going to damage these bearings in the process. Because what happens is you normally put this on, then you tighten these bolts up here, and then this bearing separator here kind of just grabs underneath the cage here, and you don't want to pull it by the cage because it's relatively weak and it'll usually break off before it actually pulls that inner bearing race off. So this clamshell one is the way to go. All right, when using the clamshell bearing puller, you have a variety of options here. The kits usually come with 3 different clamshells, and on each clamshell you have a different diameter. So it's actually like having 6 clamshells. You can see, you know, on one side it's 1 diameter, the other side. So anyway, you kind of want to size this up and find out what is going to work for your particular bearing. And it looks like this the smaller side on this clamshell here is going to work for us. Real important though to use the bearing race. So that goes on there, and I'm just putting the pinion nut up on top here because when using this gets threaded down and will apply pressure here, and I don't want to damage the pinion itself. So anyway, so get that on there, then put this over, back the top nut off here until this sits flat on here. And then we can put the clamshell around like so, just to kind of show you how this works here. And these rings here will move up and down. So basically you want to bottom this bottom one out so it's actually hitting the bearing race. So let's do that. Okay, so we'll move this down until it starts to hit. Okay, and then we'll put the clamshell on. Actually, move this down first. So put the clamshell on, and then we'll move this one up to where it touches the top part of the clamshell. So basically what it's doing is sandwiching the bearing and the race together, and we'll pull it off as one unit. And this is the reason you can grab underneath the cage and not destroy it, because it's actually really pushing up against the bearing race. So anyway, put on the other half. Pop it on here just a little bit. Okay, and then you have a little keeper ring here. Slide that over, and then thread it down. And then on top, you need to get a big socket. This is a 1.5 inch. It'll fit the top of this. And then I'll get my impact, and we'll just start impacting this down, and it should just pull the bearing off. So let's give that a shot. All right, let's go ahead and just impact it off now. And it's off, that easy. Now underneath, here's your shim. So we want to measure that and make sure that we transfer this shim over to the new pinion. All right, so let's go ahead and measure the pinion shim here and see how thick this is. So put that in here. And it's looking like 0.031 inches. All right, just went ahead and used the caliper here and measured the old and the new. And what I came up with was the old head gauge. Now this is without the shim on it, on both of them. So the old one was 1.992 inches and the new one was 1.975, which is a difference of 0.017. So we're gonna have to add 17 thousandths shim to the new head. And you can also see there's a pretty good difference in size and diameter between the two. This one has obviously fewer teeth on it, so you would expect it to be smaller. All right, so I found another pinion shim here, and this just happens to measure 0.1617. It's right there in the ballpark, so that's gonna get us pretty darn close. So I'm gonna take the old shim and put it on to the new pinion along with this old shim, which will give us an extra 17 thousandths. So now we'll go ahead and push the bearing on, and then we'll give it a try. And these old bearings, they just look too good not to reuse, so I'm gonna reuse these instead of the new ones. So anyway, before you put the bearing, press the bearing on, make sure that it's totally clean and free of debris. Same thing down there where the shims are. You don't want this to be shimmed out any more than it needs to be. Then put it on, and then what I have here is an old bearing race that I'm just going to put upside down. So when I push it on, it's only pushing on the inner bearing race, not the cage. If you push on the cage, you're going to damage the bearing. So we'll put that on like so. Okay, so now we're here on the press. Go ahead and put these plates here together, and then invert this. And then we'll just push down on the pinion until the bearing is pushed all the way on. And there we go. All right, so I went ahead and put the pinion back in, used the old nut, and I just used the impact till I got a little bit of preload on it. And as you can see here with this style wrench here, I got about 10 to 15 inch-pounds of preload. And so then I went back and checked the pinion depth, and I got 0.035. And I went back to check the pinion depth using the same method as before. And this time I ended up with 0.534. And before we had 0.536, so we're within 2 thousandths. So I'm gonna go ahead and try to set everything up the way it is now, and then we'll take a look at the gear pattern and see how it looks. And currently right now it's set up without a crush sleeve in there. So I'm gonna have to pull the pinion back out and put it back in with the pinion with a crush sleeve, and then go ahead and torque it down and put the carrier back in, and hopefully everything will line up. If not, we got a lot of work ahead of us. I'm getting a little bit ahead of myself here. We need to transfer the new ring gear over first before we do anything else. So this is a 19 mm, and I'm just gonna zip these off. Yeah, it looks like there's some kind of adhesive that's used with the initial ring gear, and looks like kind of like a hard plastic or something that's kind of in the groove here. So be sure to get all that out so that when you put the other gear on, it'll lay nice and flat. So get all that stuff off, and then we'll hit it with the wire wheel and get it perfectly clean. Okay, now we'll hit it with the wire wheel. Before we put the ring gear down onto the carrier, we clean this surface up and it's all nice and flat and smooth, but you just want to make sure that on the ring gear is nice and smooth too and free of any debris. All right, so I think we can just go ahead and put this down now. Try to line these holes up the best as possible. All right, and then once you get the bolts started, don't go to town on any one of them. Just kind of work your way around, and as you tighten each one, the next one will be loose. And that way it'll put the ring gear on nice and even, and nothing should bind up that way. That takes a little while to do it this way, but it's worth it. Okay, now we can start torquing these things down. And I found an easy way to do this, and I'm just basically going to use a breaker bar here, and then just place it through the hole where the locking pin normally goes, and then that'll hold it in place while I try to torque these things down. Okay, like so. And these bolts, they get torqued down to well, the spec on them is 97 to 102, so I'm just going to shoot for 100 and kind of do a crisscross pattern like you would on a wheel, and then just keep going until you have them all down. I'm first doing these to 70 pound-feet, and then once they're all at 70, then I'll go ahead and hit them with 100. All right, I know I said I was going to go ahead and pull all the bearings off, including the carrier bearings, but they're in such good shape, I just can't bring myself to do that. However, the procedure for pulling those bearings off would be exactly the same with that clamshell bearing puller that I used on the Pinion. All right, so let's go ahead and put the carrier back in. Of course, this is just temporary because we don't have the crush sleeve on the Pinion yet. So this is really just a test and make sure we have a good gear pattern before we go any further. So yeah, be sure to have the gloves on when you do this. I think the easiest way to do this is to have the left shim in and just leave the right one out for now, because you have to hold on the bearing races as you kind of slide it up in there. So this can be a little challenging. Once that's kind of in there, then we'll get the last shim and then try to pop that in. There we go, that's actually pretty decent there. And it's a good idea to get a shim driver like this so you don't damage anything in the spacers when you're hitting this in. You can kind of hear when it bottoms out there. That one's in all the way already. There we go. It's definitely in all the way. Okay, and then we'll put the bearing caps back on and torque them down, and then we'll check the gear pattern. We do. If it was all tight at this point, I didn't feel any kind of backlash at all, then I would just go ahead and pull it back out at this point. But I can tell that we do have a little bit of play in there. So we'll go ahead and put it back together and then test it. All right, as you can see here, we have only about 2 thousandths backlash. That's not enough, so I'm not gonna bother putting gear marking compound on it. We know it's not set up properly at this point. So let's pull it back out, re-shim it. We have thicker shim on the left side than we do on the right by 2 thousandths. So let's move the carrier over 2 thousandths that way by reversing the shims, and then see what kind of backlash we have. All right, played around with the shimming a little bit, and I got it to where it's 11 thousandths backlash. And then put some gear marking compound on here. And on the coast side, this is what it looks like. It looks like the engagement might be a little heavy near the toe, but not bad. And if we look at the drive side here, looks like it's pretty well centered, and that long swooping contact patch from heel to toe. So that looks pretty good. So I think I'm gonna go with this setup. All right, now that we're happy with the tooth pattern and the backlash and all our settings and shims, let's go ahead and pull this seal, and we'll replace that, and then I'll show you some of the components that are in here as well. Now when you pry this out, make sure that you see this little washer here. This is called an oil slinger. Don't get behind that, you don't want to destroy it. So push that in a little bit, and then right out. There we go. All right, before we go any further, let's talk a little bit about the gear setup and what all the components are. The purpose of this video isn't to not only just show you the procedures for putting it back together, but also kind of explain what's going on here. So, okay, we already know that this is the inner pinion bearing. We push that on, and we're happy with the shim, which resides right below it. And then the next thing that would go on is the crush sleeve, okay? And then on top of that is the outer pinion bearing, which goes like that. And you can see the outer pinion bearing, when we put that flange on, this is the inner race of this bearing is what's gonna crush this down. Okay, and then on top of that, we have what is referred to as an oil slinger. I think that's kind of a bad name because it doesn't sling oil at all. And I'll explain the purpose of this here in a minute. And then of course, the seal that gets pounded in to the differential, and it's gonna reside like that. And then of course, the flange goes on top of this with the pinion net. Okay, so first of all, let's talk about oil slinger. Why do we need this? It doesn't sling oil, and it's not a shim. I've heard it referred to as a shim before. It doesn't really shim anything. So what's the purpose of it? Well, when the gears are spinning fast, if you look at the rear differential, you'll see that there's kind of a little tunnel where the oil comes back up here to lubricate this outer pinion bearing. And so when it's going real fast, it can create a high pressure. And so the purpose of this is to prevent that high pressure oil from pushing against this seal here and then causing a leak. So really what this is doing is shielding the pinion seal from the high pressure oil to prevent leaks. So it resides right here, and that goes here. And you can see that with that right up against the seal, that it's gonna protect around the seal here to prevent anything from leaking. So really it should be called an oil slinger shield. And so that's the purpose of this. Important, if you don't put that in, you're likely to end up with a leak in the seal here. Okay, so the crush sleeve. Why do we need a crush sleeve? What does that do? Well, when you put this pinion nut on, there's two different settings that we need to worry about. One of which is, of course, the torque for the pinion nut. And if you'll notice that in the instructions, there's no torque setting for this. The reason being is this crush sleeve is what creates the torque setting for the pinion nut. It's going to take so much torque to start crushing this sleeve down. So we don't worry about the torque setting on the pinion nut. What we do worry about is this nut, as this sleeve gets crushed down, these two bearings get closer and closer together. So it's getting squished into that housing there. And as it gets squished, it creates what we call preload. And that's the resistance, the turning resistance of this pinion in the housing there. And if it's too loose, you could have some play. If it's too tight, you're going to create a lot of additional friction. The spec on it, oh boy, I'm not going to remember it exactly, but for used bearings, it's something like 10 to 20, and for new bearings, it's something like 15 to 29 or something like that. I'll look it up later and let you know when we put it back into the car. We're going to reuse these bearings, so we're going to use the lower preload on it. The reasoning behind that is the new bearings have a higher preload because the thought is they're going to wear in and break in a little bit, and that preload will diminish over time. So that's the reason for the two different preloads depending on the bearings that you use. So, okay, is there an alternative to a crush sleeve? Yes, there is. You can get a solid metal spacer here. And the setup for that's going to be a little different. Basically, the solid sleeve would come with some shims, and you would basically reassemble this, and then you would have a torque setting for this because the crush sleeve isn't going to determine the torque setting, so it's probably around 200 pound-feet or something like that. And so anyway, you would put this on, and then you would measure the rotational or the preload. And if it's too much, then you would take some shims out. If it's too little, you would add some shims. So it'd be a little bit of playing around to get it set. It's definitely more difficult than the crush sleeve. So what's the advantage to that? The advantage is if for some reason you ever have a seal that goes bad, you have to be real careful when you reassemble it because this can only be crushed one time. If you crush it any further, the preload is going to become too high. So anyway, when you take this nut off, and then pull the seal out and then put it back on, the fear is that, you start ramping this down and then you get to the point where it starts to crush the sleeve more, and now your preload's too high. Whereas if you used a solid spacer, you would just go to that torque setting. This is never going to compress because the solid spacer is not designed to crush. So you'd always have the proper preload. So it would make it easier to swap out a seal later. And I've also heard that if you're really rough on them, if you're off-roading or maybe drag racing, putting 1,000 horsepower to it, that the crush sleeve could potentially get crushed a little more. I'm not sure about that, if that's true. I've never seen a problem with a crush sleeve, but this is by far the easier way to go, at least initially. So anyway, that's how the rear end is set up on one of these. One other quick note, if you did decide to go with a solid spacer, the way to attack it, I think, would be to take the old crush ring off and then measure the thickness of it, and then find some shims that would go along with the spacer so it would be equivalent to that. At least that would be a great starting point. So one more point, just to make it really clear, without the crush sleeve, if you were to take this pinion nut and then put everything down to around 200 pound-feet, which is what's required by this pinion nut, the preload would be so high on these bearings that it wouldn't even spin. So again, this is the way to provide a minimal amount of force between the two bearings while still having a lot of torque on the pinion nut. Okay, a couple things I wanted to show you here, especially since we're not going to pull these bearing races since we're using the same bearings. You always want to keep the bearings in the race together. Sometimes there is difference in taper in the bearings, so you definitely don't want to use a race that has a different taper than the bearing. If you were to pull these bearing races out, you can see these little protrusions here or indentations here. You just stick a metal drift in there and then just pound it out with a hammer. And same thing on this side, but you just do it from the other side. The other thing I wanted to show you was how does that outer pinion bearing get lubricated? It's through this little tunnel here. As the ring gear spins around, it forces the gear oil down here, and then it'll pop up over on this side here where the outer bearing is. All right, now we're to the point where we can actually start reinstalling things. I'm going to start here with this brand new pinion seal, and we're going to use a seal driver to do that. And so I found the size that will appropriately fit the seal here. So we'll go ahead and use this one. All right, so let's put the seal on. Now, before we put the new seal on, we've got to make sure that we have the new outer, or actually the old bearing in here, along with the oil slinger. And then once those are in, then we can go ahead and pound in the new seal. Okay. Okay, now we're going to put the pinion in for real this time. So make sure that you got a brand new crush sleeve on it before you put it in. And then it'll come in from the back side. Also, one other thing to note, I know a lot of videos they mention you probably should put some sealant around these splines because the oil can leak through the splines and then eventually out through the pinion nut. But if you look at the pinion nut, it has a sealant on the outer side as well as the inside. So even if oil were to make it through here, which I'm sure it does, it's going to seal up against this pinion flange. Let me get that real quick and show you. So this sealant here is going to seal up against the edge of that. So you won't have to worry about leaks. So I wouldn't bother putting in any kind of sealant. It'll just make it more difficult next time you have to pull it apart. Okay, so we got our new crush sleeve on. And we can push this through here now. Be careful and try not to damage the seal at all. Okay, we got that through. And now we can kind of get this on a little bit here. Okay, there's enough at least to get a few threads going on here. Okay, now next we're going to have to get, see there's still a lot of play in here. So we're going to have to get the pinion holding tool, and then we'll start torquing this thing down. Okay, so here's the pinion flange holding tool. I just made my own. I got just some flat metal here, flat steel, and then drilled some holes in it that match up with the pinion flange here, and then just run those bolts through there. And then this will hold it while we torque that nut down. Okay, now this nut will be fairly easy to spin initially until we get down to where it actually starts crushing the ring. All right, I just looked up the spec for the preload, and as you can see here, if you're using used bearings, it's 8 to 14 inch-pounds. And for new bearings, it's 16 to 28. So anyway, I got this on here. I definitely have some preloaded because I can feel it. And it looks like we have right around 10, maybe 9. So anyway, that's perfect. And I like to be on the low end just in case you do have to replace the seal at some point and you don't want to pull this whole rear end apart. You know, you got a little bit. And the way I would do that if I was having to change a seal out is I would measure, I know you can have the axles and everything in there, but free everything up and see what kind of preload you have. It's obviously going to be much higher because you're going to have axles on there, wheels and all that. But anyway, measure it and see what it is. And then when you go to put it back on to where it just starts to get tight, and then just a fraction more, and then measure the preload again. That difference will be the additional preload on those bearings. So if you're at 8, I mean, you can increase it a little bit and not have to worry. I just went ahead and put the rear end back in. These bearing cap bolts get torqued from 90 to 100 pound-feet, so I just went ahead and went to 95 on those. And checking the backlash for the final time here. Looks like we're right there at 10 or 11 probably 11, so that's good. That's within spec. Our spec is between 8 and 12. I'm gonna put some more gear marking compound on it to look at the pattern. And here is the pattern on the drive side. Looks pretty good, looks centered, and it's long sweeping from one side to the other. And then on the coast side, about the same. So I think this is a good setup. So we can go ahead and start reassembling. All right, now we go ahead and put the axles back in. Remember, the long axle goes in on the passenger side. Now let's get all the excess off of here. I did go ahead and clean up the tone ring here a little bit. And when we put this back in, make sure that you don't drag it along the bottom of that seal there. We certainly don't want to damage it. So let's kind of slide her in. Have to twist a little bit. And then once it's in, there we go. Another thing to note, the wheel bearings here, they're actually lubricated by the gear oil. The oil from the differential actually flows down the axle tube itself to lubricate those bearings. All right, then now with the axle pushed in, we can put our C-clips back in. I'm just going to use a long-handled pliers here. And remember, this has a smooth edge and a sharp edge. We want the sharp edge towards the inside of the housing here. Okay, and that's pushed on. Now I can go over there and pull the axle out. There, that one's locked in. And then I'll just do the same thing on the other side. Now we can put back in the differential locking pin and hole on one end. That's going to coincide with right here. So now the axles are pulled back out. They should slide in freely. And then we'll put a new locking pin bolt in here, and you should use a new one. And that gets torqued down to 22 pound-feet. Now we can go ahead and put, and the same thing goes with this locking shaft bolt, because it just wants to turn until we have some kind of resistance on there. So we'll get the brakes on, and then we'll torque that along with the drive shaft. All right, now we'll go ahead and put the brakes back on. All right, you know, these rotors are so worn. There's such a large ridge around the edge here. I probably should not have done it this way. I probably should have taken the caliper off first, then take the pads out, and then the caliper bracket. And to get it back, I think I'm going to do that. Okay, now we can separate the bracket. Okay, this will be a lot easier. So here's the caliper bracket, so we'll just take the pads out, and then we'll bolt this on separately, and then that way the ridge will not be an issue at that point. I got the bracket back on. These on the rear of the S197, the bracket itself gets torqued to 79 pound-feet, and then the actual caliper here gets torqued to 26 pound-feet. It just goes to show you, every time you try to take a shortcut, it usually comes back to bite you. I don't know why I haven't learned that yet. I tried to take the easy way out, and now it's just making it more difficult. Okay, this would be a great time to lube up all the hardware and the sliders and all that, but I'm going to replace these brakes soon. All right, now we can go ahead and torque them down. And the spec on this is 24 pound-feet. I think I said 26 last time. Now just repeat the process on the other side. I won't bother filming that since it's redundant. All right, now we can go ahead and put the wheel speed sensors back in. Okay, the torque spec for these wheel speed sensors are 133 inch-pounds. All right, the best way I found to get the torque setting on this Pinion locking bolt is to have one of these type of rounded off heads, so you can kind of go in at an angle a little bit. And this is an 8mm, so then I got a long extension here, and then I can put the torque wrench here, and this gets torqued to 22 pound-feet. I do have the brake on now so it doesn't rotate, and now we can go ahead and tighten up the bolts on the drive shaft. I apologize, my camera has been malfunctioning a little bit. I had to, in the last section that I edited video, I noticed that some of the clips, they went into slow motion. Sometimes they were flickering, and sometimes they were just cut short, so I don't know what's going on. But anyway, the things that I've done off camera, I guess, are put on the rear diff cover. Pretty straightforward, just a gasket, and then these get torqued to 33 pound-feet. I put the panhard bar back on that gets torqued to 129 pound-feet, and then the end links for the sway bar, 89 pound-feet. So anyway, I think we're about ready to go ahead and put some fluid into the differential, and then put the wheels back on and give it a test drive. All right, I converted one of these weed sprayers to a pressurized fluid filler, and so what I'm going to do is put 2 quarts into here along with the friction modifier, knowing that the differential is going to use all that fluid, and then once all that is in, then I'll go ahead and get another bottle and then top it off. But that will ensure that we get the full 4 ounces into the diff. All right, now I'll go ahead and add the friction modifier. This is the stuff that is very stinky. And the reason we need the friction modifier, you only need it first of all in the rear ends that have the traction lock, which are basically the rear ends that have the limited slip. They use some clutch packs. And what this does is it makes the fluid a little more slippery, so the clutches don't grab quite as hard. If you don't add the friction modifier, the inside wheel will tend to skip and hop. So if you do have that problem, you probably didn't add this, or you may need to add a little bit more. Okay, but I don't think I would ever add more of this unless I absolutely needed to, because if you get too much in there, the fluid becomes too slippery, and then the clutch packs won't operate like they're supposed to, and basically you're going to lose your limited slipability. Okay, and then the fill hole is right here on the driver's side axle. And basically it's just a 3/8 inch ratchet. Will fit into the plug. And then just take that out. And this is designed it's fill to spill. So basically you're gonna put fluid in this until it starts to leak out. Put the tube into the hole there, and then we'll just open up the valve here, and it should start flowing up and into the differential. All right, now we just wait for it to fill. And once it starts to leak out up here, we'll go ahead and pull it out and put the cap in, and we're done. All right, looks like we almost have our 2 quarts in. We should see it start pumping air here in a minute. Just about through. It should start pumping air here in a moment. See, it's still not leaking out. There we go. And see, there's our 2 quarts, and we're still not leaking out yet. All right, and here's where you're going to need your 3rd quart. We'll probably only need about 1/4 to 1/2 of this. So let's go ahead and add a little bit more in, and then just repeat this procedure until we start to overflow. Okay. Okay, let's wait for it to start to flow out and then we'll cap it. There we go, it's coming out, so we're done. Well, I just got it back from a test drive. We got up to freeway speeds and we accelerated, deaccelerated, listened for any gear noise and didn't detect any, so it looks like this was a success. Got it back, looked under the car, no leaks or anything. So the only thing left to do now is to correct the speedometer, and with this car I'm going to do it with a little handheld unit. So, and then it's kind of late in the year, so I probably won't get it out to the track, but as soon as the track opens up again, we'll get this out and see if the gears have improved its quarter-mile time. The last time I took it out, it ran at 1280 to something like 115. So hopefully we can do better on that. If you found this content useful, please like, subscribe, and click the notification bell so you'll be notified of any new and upcoming videos. Until then, we'll see you next time. Bye-bye. Thanks for watching.